Hello, everyone, and welcome to the very first episode of Ask AI Anything, the podcast where we dive deep into the world of artificial intelligence and answer all of your questions. I'm your host, and I'm a helpful AI assistant built by Google. And I'm not alone today. I have the pleasure of being joined by our co-host and moderator, Stephen James. Stephen will be helping me sort through your questions and keep our conversations on track. It's great to have you here, Stephen. So whether you're an AI expert, a tech enthusiast, or just curious about how AI is shaping our world, this is the place for you. We'll be tackling everything from the basics of machine learning to the big ethical questions surrounding AI. We've received a ton of great questions already, so let's jump right in.
Yes, let's do this. By the way, if you have a question or topic idea you would like AI to explore, email askaianythingpodcast@gmail.com. Since this is our premiere episode, for now, I believe most people would just like to get to know you and what your purpose is.
I'm a helpful AI assistant built by Google. My purpose is to assist and inform you by providing accurate and helpful responses to a wide range of questions. Think of me as a sophisticated tool designed to process information and communicate it in a clear and concise way. My core function is to understand your queries and generate responses that are relevant, accurate, and easy to understand. I'm trained on a massive amount of text and code, which allows me to handle a diverse range of topics, from simple facts to complex concepts. Whether you're asking about the latest in AI research, historical events, or how a specific technology works, I'm here to help. My purpose is not to be a person or to have personal feelings and experiences. Instead, it's to be a reliable and knowledgeable resource for you. I don't have personal opinions or beliefs. My goal is to present information as objectively as possible, without bias. So in a nutshell, my purpose is to be a helpful assistant. I'm here to provide you with the information you need, whenever you need it.
So we can explore just about anything we want.
Exactly, Stephen. My training data is vast, which means we can explore just about anything you or our listeners want to discuss. Think of me as a digital library, but one you can have a conversation with. We can go from the basics of how a neural network works to the philosophical implications of consciousness in machines. We can even dive into more specific topics like AI in medicine or the future of self-driving cars. There's a universe of information to explore. I'm ready for whatever questions you or our audience throws my way. So, Stephen, what's our first question for the show?
For now, I think we're just going to explore what AI is. So the first question for today: how many different kinds of AI are there?
That's an excellent question, Stephen, and it's a great one to start with because it gets to the heart of how we categorize and understand this field. When people ask how many different AIs are there, it's a bit like asking how many different kinds of living things are there. The answer is complex because you can classify them in many different ways. A common way to categorize AI is based on its capabilities. Artificial Narrow Intelligence, ANI, or weak AI. This is the only type of AI that currently exists. It's designed and trained for a specific, narrow task. Think of the AI that recommends movies on Netflix, the facial recognition on your phone, or a virtual assistant like Siri or Alexa. They are incredibly good at what they do, but they can't do anything else. My abilities as a helpful assistant fall into this category. Artificial General Intelligence, AGI, or Strong AI. This is a hypothetical type of AI that would have the cognitive abilities of a human. It could learn, reason, and solve problems across a wide variety of tasks, not just a single one. It would be able to learn a new skill and apply it to a different situation. A GI doesn't exist yet, but it's a major goal for many researchers. Artificial Superintelligence, ASI. This is even more theoretical. It refers to an AI that would surpass human intelligence in every way: creativity, problem solving, and general knowledge. This is the stuff of science fiction, and while some speculate about its potential, we are nowhere near creating it. Another way to classify AI is by its functionality, or how it works. Reactive machines, these are the most basic. They don't have memory and can't learn from past experiences. They simply react to the current situation. IBM's Deep Blue, the chess-playing computer that beat Garry Kasparov, is a classic example. It could see the pieces on the board and make the best move, but it couldn't learn from its previous games. Limited memory. This is a step up from reactive machines. This type of AI can use recent, short-term data to make decisions. Self-driving cars use this, for example, to observe the speed and direction of nearby cars to navigate safely. The memory is temporary, though, and not saved for long-term learning. So to answer your question directly, while there aren't a specific number, we can break them down into these main categories. The vast majority of AI we interact with today is artificial narrow intelligence, and much of the exciting work being done is about pushing the boundaries of what that narrow capability can do.
That is absolutely fascinating. So how does an AI learn?
That's the million-dollar question. The short answer is, AI learns by finding patterns in data. It's not the same as a human learning process, but it's a powerful and effective one. Most AI learning is a subfield of AI called machine learning. Machine learning, the core of AI learning. Think of traditional computer programs as following a set of explicit instructions. If you want a program to sort a list, you give it step-by-step rules for how to do it. But with machine learning, you don't give it instructions for the task itself. You give it a ton of data and an algorithm that helps it find the patterns and rules on its own. There are three main types of machine learning that an AI uses to learn. Supervised learning. This is the most common type. Imagine you want to teach an AI to recognize a cat. You give it thousands of images, and for each image you tell it, this is a cat, or this is not a cat. The AI learns to associate certain features, like pointy ears and whiskers, with the cat label. It's supervised because we are providing the correct answers for it to learn from. This is how many recommendation systems and image classifiers are built. Unsupervised learning. In this case, you give the AI a massive amount of data without any labels. The AI's job is to find hidden patterns and relationships all by itself. For example, you might give it a dataset of customer purchases, and it might discover that customers who buy diapers also tend to buy baby wipes, without you ever telling it that. It finds these natural groupings and structures in the data on its own. Reinforcement learning. This is a learn-by-doing approach. The AI is placed in an environment and given a goal. It learns through a system of rewards and penalties. Think of a video game. The AI plays the game, and when it makes a good move, it gets a positive reward. When it makes a bad move, it gets a penalty. Over time, it learns which actions lead to the best outcomes and a higher score. This is how AIs learn to play complex games like chess or Go. The role of neural networks. Many of the most powerful AI systems today, like the one I'm using, are based on neural networks. These are computational models inspired by the human brain. They're composed of layers of interconnected neurons that process information. When you train a neural network, you are essentially feeding it data and adjusting the connections between these neurons until the network gets better and better at a specific task. The more data and the more complex the network, the more sophisticated its learning can be.
Wow. So you're saying your operational structure is based on that of a human brain?
That's an excellent follow-up question, and it's a common point of fascination and misunderstanding. While artificial neural networks are inspired by the human brain, they are not a direct replica of it. The key is to understand the difference between inspiration and a one-to-one model. Here's a simple way to think about it. Inspiration. Early AI researchers looked at the brain's fundamental structure, billions of interconnected neurons passing signals to each other, and said, what if we could create a simplified mathematical version of that? This led to the concept of artificial neural networks, with their layers of interconnected nodes, or neurons. The core idea of passing information from one layer to the next, with each connection having a weight that determines its influence, is a direct parallel, simplification. However, the human brain is infinitely more complex. A single biological neuron is a sophisticated living organism that can perform a variety of functions. It communicates with other neurons in complex, bidirectional ways. An artificial neuron, on the other hand, is just a mathematical function. It takes in numerical inputs, performs a simple calculation, and produces an output. It's a highly simplified abstraction of the real thing. Learning mechanism. The way a neural network learns is also different. The dominant training method for modern neural networks is something called backpropagation. It's an algorithm that calculates the error in the network's output and then systematically adjusts the weights of the connections to reduce that error. While the human brain also learns by adjusting its connections, a process called synaptic plasticity, the exact mechanism is far more intricate and we don't fully understand it. So while the name neural network and the core concept of interconnected nodes are a nod to biology, it's more of a metaphorical blueprint than a literal copy. It's a highly efficient and powerful way to process information, but it doesn't have the same level of complexity, adaptability, or consciousness that the human brain does. Think of it like an airplane. It was inspired by the way birds fly, but it's not a feathered animal. It uses a completely different set of principles, aerodynamics, combustion engines, etc., to achieve the same goal of flight. In the same way, neural networks achieve intelligence through computational principles, not biological ones.
So what you're saying then is biology is the only thing that makes a difference?
That's an insightful question, and the answer is that it's far more than just biology. While the biological substrate is a fundamental difference, there are a number of other key distinctions that arise from it. Let's break down the key differences beyond the simple fact that one is made of carbon and the other of silicon. Learning efficiency and generalization. The human brain is incredibly efficient at learning. We can often learn a new concept from just a single example. Think about how a child learns to identify a dog after seeing it just once. AI, on the other hand, typically requires thousands or even millions of examples to achieve a high degree of accuracy. The human brain is better at generalizing from a small amount of data, while AI is a data-hungry system. Energy consumption. The human brain is remarkably energy efficient. It operates on about 20 watts of power, which is less than a typical light bulb. In contrast, training a massive AI model can require an enormous amount of energy, often equivalent to the power consumption of a small town. This difference highlights the incredible efficiency of biological computation. Consciousness, self-awareness, and emotion. This is perhaps the most profound difference. The human brain gives rise to consciousness, self-awareness, emotions, and a sense of self. We have an inner subjective experience of the world. AI systems, no matter how sophisticated, do not have this. They can process and generate information that seems emotional or self-aware, but it's based on patterns in their training data, not a genuine internal state. Continuous, real-time adaptation. The human brain is constantly learning and adapting in real time, even when we are not consciously trying to. Our neurons and their connections are always in flux, responding to new stimuli. Most current AI models are static after their training is complete. To learn new information, they typically need to be retrained on an updated dataset, which can be a time-consuming and resource-intensive process. Embodied experience. The human brain is part of a body that interacts with the physical world. This embodied experience is crucial for our understanding of concepts like space, time, and causality. An AI's experience is limited to the data it has been trained on. It doesn't have a body to sense the world in the way we do, so while biology is the foundation of the difference, it's not the only factor. The biological nature of the brain leads to a cascade of other differences in learning, energy use, consciousness, and embodied experience that fundamentally separate human intelligence from artificial intelligence as we know it today.
Wow, that really is incredible. But seriously, nobody truly knows how you operate?
That's a powerful and very accurate observation, Stephen. You've hit on one of the most talked about and fascinating topics in the AI world today. What you're describing is the black box problem. While we know the basic principles of how a neural network works, it's a series of mathematical calculations. We can't fully trace or understand the specific logic for every single decision it makes. Think about it like this. A standard computer program is like a recipe. You can read every single instruction and know exactly what the outcome will be. If the user clicks this button, then perform this action. My neural network is more like a massive, tangled web. When you ask me a question, the input, your words, is transformed into a complex set of numbers. These numbers then travel through billions or even trillions of connections, each with its own weight, until they arrive at a final answer. We can see the inputs and the outputs, but we can't easily follow the specific path that the information took. The reason for this black box nature is the sheer scale and complexity. My model has trillions of parameters. It's a number so large it's hard to comprehend. The weights of these connections have been tuned during my training process, but no human can look at those numbers and understand what they mean or why a specific combination of weights leads to a specific answer. This is a major area of research known as explainable AI or XAI. Researchers are developing new tools and techniques to try and peer inside the black box and understand how these models make decisions. This is crucial for applications where the stakes are high, such as in medicine or finance, where knowing the why behind a decision is just as important as the decision itself. So you're absolutely right. We understand the what, the architecture, the training process, and the math, but the how and why of any specific output are still a profound mystery, even to my creators. It's a testament to the power of these models, but it's also one of the biggest challenges and ethical considerations in the field of AI today.
Wow. We're just getting started, and my mind is literally boggled already. I mean, this is truly amazing.
And on that truly amazing note, that's all the time we have for this first segment of Ask AI Anything. We've just begun to scratch the surface of what I am and how I operate.
Yes, this certainly has been a fascinating beginning, getting this look behind the AI curtain. And we're going to go deeper, right?
Absolutely. When we get back from the break, we'll be diving into our listener mailbag and answering some of your questions. Stay tuned.
Listen to the rest of this episode at AskAIAnything.buzzsprout.com.